This is pre-AP, Precalculus, section 10.3. We're going to use the trig sum and difference identities. So let's start right down here and we'll backtrack. Consider for a moment the expression sine of 45 degrees plus 60 degrees. Obviously, this is equivalent to the expression sine of 105 because 45 plus 60 is 105. But the real question is, does the expression, this expression here, equal sine of 45 plus sine of 60? So let's figure this out. If you use your calculator and put it in degree mode and you type in sine of 105, you're going to get 0.966. However, if you put in your calculator in degree mode sine of 45 plus sine of 60, you're going to get 1.573. Interesting. What conclusion can we reach based upon what's above? Here's the conclusion that we can reach based upon what's above. Sine of 45 degrees plus 60 does not equal sine of 45 degrees plus sine of 60 degrees. The mistake people make is they try to say, well, this is sine times this, so we distribute it. But it's not sine times it. Sine is its own function. So it's not being multiplied. This is not the distributive property. And that leads us to these sum and difference identities. These need to be memorized sooner than you actually read this. So the fact that you're watching this now means that this should have already been memorized. Yeah, I know, I get it. Get it done. Let's focus on sine first. So if you have sine and then you are adding two angles, could be in degrees or radians, it doesn't matter. That's equivalent to sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the second angle. Now you can write this in a couple different ways. So you could write it like that. I didn't give a lot of room to write this in a different way. Or you could write it as sine of A plus B is sine of A cosine of B plus sine of B cosine of A. That's equivalent to this down here. Whichever one makes more sense to how you're going to memorize it is the way that you should do it. I personally like to have my sines both first, my cosines both second, but it really doesn't make a difference. The next one, sine of A minus B, it's the same thing, but instead of a plus, we have a minus. Once again, this needs to be memorized. It has to be. Then we have the cosine sum of difference identities. Cosine of alpha plus b, you're going to have cosine of your first angle times cosine of your second angle. Notice how the sign here is different. Minus, it was a plus, it's a minus. Sine of your first angle times sine of your second angle. Similarly, cosine of a minus b is going to be a plus. You have cosine of your first and second angle be multiplied together, and then you have sine of your first angle times sine of your second angle. Then we have the sum of difference identities for tangent. So tangent of alpha plus beta, or a plus b, depending on what variables you're using. You have tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. Then the subtraction one is the opposite. You got minus on the top and you got plus on the bottom. So yes, those need to be memorized. You need to do it before you start doing your homework. Use the formula sine sum identity to find the value of sine of 45 plus 60. What do you notice? Well, let's see. Sine of 45 plus 60 degrees is equal to sine of 45 times cosine of 60 plus sine of 60 times cosine of 45 degrees. Using the unit circle, sine of 45 degrees is square root of 2 over 2. Using the unit circle, cosine of 60 degrees is 1/2. Using the unit circle, sine of 60 degrees is square root of 3 over 2. Using the unit circle, cosine of 45 degrees is square root of 2 over 2. Remember about a month and a half ago when I said you learn the unit circle? We're going to be using it forever. Yeah. Simplifying each of these terms, we're going to have square root of 2 over 4 plus square root of 6 over 4. If you're multiplying two radicals, you multiply the inside numbers together. We already have common denominator, so to add this together, we're going to get square root of 2 plus square root of 6 over 4. It does not simplify anymore. If you were to put that into your calculator, this fraction, guess what you would get? You would get 0.960. What do we notice about that? Well, you should notice that's the same as 105, sine of 105, and that's because 45 plus 60 is 105. Yay! Find the exact value of sine of 15 using two angles from the unit circle whose difference is 15. Well, we could say that sine of 15 degrees is equivalent to sine of 60 degrees minus 45 degrees. Now, the reason we want to use angles from the unit circle is because we know what sine of those angles are without doing any work, without using a calculator. So we are trying to take an angle that we're given and change it to a sum or difference of two special angles. Special angles are multiples of 30 and multiples of 45. Using the difference sum identity, we're going to have sine of 60 degrees times cosine of 45 degrees minus sine of 45 degrees times cosine of 60 degrees. Sine of 60, using the unit circle, is square root of 3 over 2. Cosine of 60, I'm over here on the right, is going to be 1/2 using the unit circle. Cosine of 45, square root of 2 over 2. Sine of 45, square root of 2 over 2. When you're multiplying two fractions, you multiply the tops and the bottoms. Oh, no, that's right. And then once you have common denominators, which we already have, you subtract the tops and not the bottoms. You can't subtract square root of 2 from square root of 6. They are not like terms. So that is the correct exact answer for sine of 15. Number 2, find the exact value of sine of 285 using two angles from the unit circle whose sum is 285. Well, sine of 285, by the way, you can choose different angles that what I'm going to choose because there's lots of angles that work. That's going to be the same as sine of 240 degrees plus 45 degrees. Using the sum identity for sine, that's going to be sine of the first angle times cosine of the second angle plus sine of the second angle times cosine of the first angle. So cosine of 240 degrees, that's going to be in quadrant 3, which makes the reference angle 60. In quadrant 3, things are negative. So if we make this a unit circle, that means that the x value here is going to be negative 1/2, and the y value is going to be negative square root of 3 over 2. So sine of 240 is negative square root of 3 over 2. Most common mistake people make on this is they don't use the appropriate negative sign. Cosine of 45 is in quadrant 1, that's square root of 2 over 2. Sine of 45, square root of 2 over 2. Cosine of 240 is negative 1/2. Simplify this, you get negative square root of 6 over 4 plus negative square root of 2 over 2. That makes this negative square root of 6 minus square root of 2. This is over 4, not 2. 2 times 2 is 4, folks, not 2. We could factor a negative out if we wanted and make this square root of 6 plus square root of 2 over 4. Got this negative out here in front. It's not something you would have to do. That's what sine of 285 is. Degrees. All right. Simplify each of the following using a sine, sum, or difference identity. Well, this is going to equal sine of x times cosine of 2 pi over 3 plus sine of 2 pi over 3 times cosine of x. Don't know what sine of x is? Cosine of 2 pi over 3, that's going to be in quadrant 2. Let me just draw that. Makes the reference angle pi over 3. This is negative, so that makes this negative 1/2. That makes this square root of 3 over 2. It makes this 1. So cosine of 2 pi over 3 is going to be negative 1/2. Sine of 2 pi over 3 is going to be square root of 3 over 2. We could write this, let's multiply this together, so we get negative sine of x over 2 plus square root of 3 times cosine of x over 2. We have common denominators, so let's add this together. We also like to put our positive thing first. So that's what that simplifies to. Not that simple, but that's the best we can do. Number 4 is going to be sine of pi over 2 times cosine of theta minus sine of theta times cosine of pi over 2. Sine of pi over 2 is 1. Don't know what cosine or sine of theta are. Cosine of pi over 2 is 0. That just makes this cosine of theta. Pretty simple. Number 15. Oh, this is interesting. Sine of 75, that's not on the unit circle. Cosine of 15, not on the unit circle. Oh, this is a sine sum identity. This is equivalent to sine of 75 plus 15. 75 plus 15, that's 90. That is on the unit circle. Sine of 90 is 1. That's interesting. That requires you to recognize this is a sum identity. Now, these are in a different order than what I prefer, but it doesn't change the fact that it's still true because of the commutative property. Those can be in either order. Let's see, this one here, this is the same as sine of 290 minus 50. That's sine of 240. Now, what is sine of 240? That makes a reference angle here of 60. That makes this negative square root of 3 over 2. That's a negative square root of 3 over 2. Pretty awesome if you ask me, and I realize you never asked me. All right, number 7, use sum or difference identity for cosine to find the exact value. All right. Oh, it also says use a calculator to approximate the value. Yeah, I'm not going to use a calculator. You can do that if you want, but I'm not going to. I'm a rebel that way. So cosine of these two angles is going to equal cosine of the first angle times cosine of the second angle. Change the sign of what the sum was, so it's a difference. Then you have sine of the first angle times sine of the second angle. Cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 2 is 0. Sine of pi over 6 is a half. Sine of pi over 2 is 1. That makes this negative 1/2. If you were to put that in your calculator, you would get negative 0.5. Number 8, cosine of 120 minus 45, that's going to be equal to cosine of 120 degrees times cosine of 45 degrees minus sine of 120 degrees times sine of 45 degrees. Sine of 120 is in quadrant 2, reference angle 60, that makes this negative 1/2. Got to know unit circle, folks. Cosine of 45, square root of 2 over 2. Sine of 120 is in quadrant 2, sine's positive in quadrant 2, that is square root of 3 over 2. And sine of 45, oh, that's a hot mess over there. That's square root of 2 over 2. So this is going to give us a negative square root of 2 over 4. When you multiply two fractions, you multiply the tops, you multiply the bottoms. But you have common denominators, which we have. Oops, I made a mistake. This is minus. This needs to be plus. Got to be careful with cosine, and I just about flubbed the give on this. If you're subtracting, it's plus. What's nice about cosine is it matches up the cosines together, it matches up the sines together. What's not nice about it is that the signs are different. What's nice about sine, let's look at one of these signs. What's nice about sine is the sign between the angles and the expressions are the same. What's bad about sine is it matches sine and cosine together. So be really careful, and I just about messed this problem up. That's going to be negative. We like to put our positive first. We're going to have positive square root of 6 minus square root of 2 over 4. If you put the negative square root of 2 first plus square root of 6, that would not be counted wrong, by the way. Put that in your calculator if you want. You can get the approximate value. The directions stated that we should, but I just don't feel like it. What if you don't feel like it? Well, you got to do it anyhow. All right, number 9. Find the exact value of tangent of 75 using two angles from the unit circle whose difference is 75. Well, tangent of 75 degrees is the same as tangent of 120 degrees minus 45 degrees. Using the difference identity for tangent, that's going to be tangent of 120 degrees minus tangent of 45 degrees over 1 plus tangent of 120 times tangent of 45. What is tangent of 120? Well, let's do a little bit of side work that's not required, but if you need to do this to get it right, then you should do it. So tangent, do this in a couple different ways. I'll show you the way that you're probably going to want to do it, and then I'll show you the way I would do it. There's a unit circle. Opposite 30 is going to be negative half because we went left. Opposite 60 is going to be square root of 3 over 2. Tangent of 120 is y over x. If you multiply the top and bottom by 2, you're going to end up with a negative square root of 3. Or, here's how I would do it. If I'm using tangent, if I'm using any trig function that's not sine or cosine, I prefer not to use a unit circle. Still use the reference triangle. I like to call the smallest side 1. The long leg is going to be that times the square root of 3, but it's positive. And then the hypotenuse is double the short leg, but the hypotenuse is always positive. Then tangent of 120 is y over x, which is just negative square root of 3. Either way you get there, that's cleaner for me in my brain. So this is negative square root of 3 minus. Then, let's see, we're going to have tangent of 45, which is 1 over. Then we're going to have 1 plus tangent of 120, we just said is a negative square root of 3. And then tangent of 45 is 1. That makes this negative square root of 3 minus 1 over 1 minus the square root of 3. We could rationalize the denominator, but I think at this point we're not going to, just because it's just so much effort and work and there's so little payoff. We could factor negative out of the top and bottom. Let's do that. If I do that, that's going to make this, because those negative ones cancel, square root of 3 plus 1 over square root of 3 minus 1. There you go. Let's check out number 10. Find the exact value of tangent of 165 using two angles from the unit circle. So I'm going to use tangent of 120 and 45. Tangent of 1, that's going to be equal to tangent of 120 degrees plus 45. This is going to be real easy because it's the same angles we just used. Just the signs are going to be different places. 1 minus tangent of 120 times tangent of 45. And I messed up my numerator because I'm getting ahead of myself. It's not just 45, it's tangent of 45. Tangent of 120 we just found is negative square root of 3. Tangent of 45 is 1. We have 1 minus negative square root of 3 times 1. We could rewrite this as 1 minus the square root of 3 over 1 plus the square root of 3. Once again, we could rationalize our denominator, but for the time being, I'm going to say don't sweat that for these tangent ones because it's a ton of work and very little payoff. Number 11. Suppose sine of theta is 3/5 and sine of alpha is 5/13. Additionally, tangent of theta is greater than 0, and tangent of alpha is less than 0. Draw angles theta and alpha, labeling the reference triangles. So that's one thing we're supposed to do. And then find values of these three things. All right, so let's do these angles first. Let's focus on sine of theta. If sine of theta is 3/5, that means it has to be in quadrants 1 or 2 because the y value 3 is positive. Since tangent of theta is greater than 0, it has to be that x and y are both positive. Or they're both negative, that'd be the same sign. Since we know y is positive, that means that this has to be in quadrant 1. Y is 3, R is 5. Using the Pythagorean theorem, or recognize its Pythagorean triple, that makes this 4. Alpha, also once again, alpha could be in quadrant 1 or 2 because the y value is positive 5. Has to be in quadrant 2 because it says tangent of alpha is negative. That means that the sign for x and y have to be different signs. This is also a Pythagorean triple. Hope you recognize it. negative 12. If you don't recognize it, use the Pythagorean theorem. Draw angles theta and alpha, did it. Labeling the reference triangles, did it. Now we got to find these values. Sine of theta plus alpha. Using the sum identity for sine, this is going to be sine of theta cosine of alpha plus sine of alpha cosine of theta. Sine of theta is y over r. It's from this triangle here. Cosine of alpha from this triangle is x over r plus sine of alpha, that's this triangle, is 5 over 13 times cosine of theta, it's this triangle, that's x over r. It simplifies, we get negative 36 over 65 plus 20 over 65. That's going to give us negative 16 over 65. That's what tangent of theta plus alpha is. Next, we're supposed to figure out what cosine of alpha minus theta is. Excuse me. That's going to be cosine of alpha times cosine of theta plus sine of alpha sine of theta. Now, if it helps, and it probably would help, I'm just going to go up here and write down sine of theta is 3/5. Cosine of theta is 4/5. And over here we got sine of alpha is 5 over negative 12. Cosine of alpha, I'm sorry, that's 5 over 13. Cosine of alpha is negative 12 over 13. So just filling this stuff in, cosine of alpha is negative 12/13. Cosine of theta is 4/5. Sine of alpha is 5/13. Sine of theta is 3/5. It's going to give us negative 48 over 65 plus 15 over 65. That gives us negative 33 over 65. That's what cosine of alpha minus theta is. Next, we got to figure out what tangent of alpha minus theta is. Alpha minus theta? No, it says theta minus alpha. Make sure that I'm following the directions. Well, that's going to equal tangent of theta minus tangent of alpha over 1 plus tangent of theta tangent of alpha. Something that needs to be memorized. If I go up to these circles, these triangles, I should say, let me write down what tangent of theta is. That's 3/4. Here, tangent of alpha is 5 over negative 12. I'm going to just bring those down here so I can see them, so I don't have to scroll back and forth. So simplifying this, we're going to have 3/4 minus 5 over negative 12. And then I'm going to have 1 plus 3/4 times 5 over negative 12. To simplify this, I would want to get common denominators in my numerator. So that would make this 9/12 minus, well, it'll be plus 5/12. Right? So make sure. Multiply this by 3, yep. And then on the bottom, if I can simplify this a little bit. I can say divide 3 by 3 goes once, 3 goes into this, -4 times. It's going to give me 5 over -16. I'm going to change this 1 to 16 over 16. I'm also going to move this negative to be here. So it's 16 minus 5. And then that's going to give me 14/12 divided by 9/16. I am running out of space quickly. I'm writing like a person that owns a paper farm. Ladies and gentlemen, I don't own a paper farm. Some of these fractions can be reduced. We can reduce this one, this top one, to 7/6. I'm going to multiply by the reciprocal of the denominator so I can do a little canceling. Also, by the way, I did make a mistake. 16 minus 5 is not 9, that's 11. It's a noob mistake. I can divide both 6 and 16 by 2. That's going to give me 56 over 33. And if I were taking a test over this problem, I would check my work a couple times because I made a couple mistakes as I went. I think I caught them at this point, but that's tangent of theta minus alpha. Boy, there's a lot more here, isn't there? Algebraically verify the equations below are trig identities. So let's do that. Cosine of pi over 2 minus x, that's a difference identity. We can make that cosine of pi over 2 times cosine of x plus, signs are different for cosine, sine of pi over 2 times sine of x. Cosine of pi over 2 using the unit circle is 0. Sine of pi over 2 using the unit circle is 1. So this just becomes sine of x. 0 times cosine is 0. 1 times sine is sine. 0 plus sine is sine. The right side was sine of x all along. So that was pretty simple. 13, we got tangent. Tangent's always kind of a little bit of a jerk, but let's see what happens here. This is going to be, I'm going to work with the left side. I'm going to leave the right side alone. See what happens. Doubling the sum identity for tangent is going to be tangent of the first angle plus tangent of the second over 1 minus tangent of the first angle times tangent of the second angle. Tangent of pi over 4 is 1. That's going to make this tangent of x plus 1 over 1 minus tangent of x times 1. I'm going to now change tangent to sine over cosine because the right side of the equation is in terms of sine over cosine. I'm also going to change my 1's to get common denominators to cosine over cosine. We're going to simplify the numerator. There's already common denominators, so it's going to be sine of x plus cosine of x over cosine of x. My denominator, I got cosine of x minus sine of x over cosine of x. To make this not complex, I'm going to multiply by 1 in the form of cosine over cosine. If I do that, my cosines cancel. And I am left with what was on the right side all along. sine of x plus cosine of x divided by cosine of x minus sine of x. Once again, it's what the right side was. I guess it isn't. It's close. I need to make it exactly like that. Pickles. Let me bring this up here. I can reverse the order of these two things using the commutative property and get cosine of x plus sine of x. Things have to be exactly the same. Now this is going to equal what the right side was all along. Awesome. Let's do number 14. This one is an extremely important one. Mark this in your notes. Here's what happens if you try to do this using the difference identity for tangent. So I'm going to do some work, then it's not going to go anywhere. But I wouldn't know it doesn't go anywhere until I try it. It's going to be tangent of the first angle minus tangent of the second over 1 plus tangent of the first angle times tangent of the second. Well, what is tangent of pi over 2? It is 1 over 0, which is undefined. So here's a problem. You cannot work with an equation that has something undefined in it. This did not work. So let's go about this in a different way. Tangent is equivalent to sine of our angle over cosine of the same angle. Now we're not used to our angle being so complicated, but it's still sine of an angle over cosine of the same angle is equal to tangent. So I'm changing this to sine over cosine. Now watch what happens now. This is going to be on the test very likely because I like this problem. The difference identity for sine is going to be sine of the first angle times cosine of the second angle minus sine of the second angle times cosine of the first angle. The difference identity for cosine, that's going to be cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. Now what is sine of pi over 2? That's 1. What is cosine of pi over 2? That's 0. The top becomes cosine of x, the bottom becomes sine of x, and that is cotangent of x, which is what the right side was all along. Knowing to do this when this happens, super important. Last one. Simplify the expression below using the sum of difference identities for sine and cosine. I guess it's just cosine. All right, well, let's see what happens here. So this first one is going to be cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. Now let's do this part. That's going to be cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. Well, right away we can see these things cancel, right? It's the same expression, one's plus, one's minus. And then we can see these two expressions are the same. They're also like terms. It's the same term, same value, and there's two of those. So we're going to have 2 times cosine of 3 pi over 2 times cosine of x. What's cosine of 3 pi over 2? Let's check this out. 3 pi over 2 is down here. Here the x value is 0 and the r value is 1. So that makes this 2 times 0 times cosine of x. So this just equals 0. Dunsies.